Hello everyone, my name is Dave and today I'm going to repeat this video. Let's get started. The universe is pretty big and very strange. Hundreds of billions of galaxies with sextillions of stars and planets in the middle of its Earth with you and us. But enormous as the universe seems looking up, it seems to get larger when you start looking down. You're counting the worlds within worlds in each plain sight and yet hidden from your experience. Let's go on a journey and we'll start in a park about 1,000 meters long, enough for a 15 minutes walk. Every time we click this magic button, we will become 1,000 times smaller. Please sip into this magic sun suit so you don't die and can still see. Ready? The miniature realm. You're the size of a grain of sand, just 2 millimeters high, staying on a blade of grass that seems as tall as an 8-story building to you. A square kilometers of lawn is a dense metropolitan area with 100,000 of blades to imagine with a grass tower. From your new tiny perspective, the park could quickly stroll before your size now is a France. Crossing it will take at least a week. Humans loomed over you, 40 times taller than an Empire State Building. Steps falling from the horizon to horizon. A bee-sized helicopter lands near you, making the ground shake as its hairy cavalry vibrates each wing beat. You try to escape but able to move because the air is so gooey. Before you click the button, air resistance was barely noticeable. Smaller now, 1,000 times smaller, because the air become 1,000 times denser. It feels like you're moving through honey. Flying insects use bees to their advantage. Their wings are not made of gliding, but paddles through rows to rare. Scale up to human size, a bee would outrun a corner jet. Instead, it wouldn't take off because it's heavy for its wings. Click the microscopic realm. You enter this microscopic realm, and now you're at least 2 micrometers tall, about the size of E. coli bacteria. From your new tiny perspective, the park would start 1,000,000 kilometers wide. To you, it would walk non-stop, take 25 years to cross it. It's hard to grasp the huge microscopic world and tiny inhabitants. A giant bee a minute ago is the size of Mount Everest, towering into the sky, but alive, human, and vibrating. The air now feels solid to you, as a human scale would be too vicious as lava, extremely hard to push through. The blade of glass now expands so far you can't see its edges, stretching as wide as Paris as a regular-sized human. See valleys with dried up riverbeds and dead patches like deserts and giant craters left behind by geology efforts. If you look closely, this is not terrain. These are rounds of individual cells with each house with heart and cells like glass cells, which a few cells of huge opening area called stomata, like mouths sucking air in and spitting out oxygen. Suddenly, the gigantic bee begins to move, a construct made of rigid pieces slide against each other like a suit of armor. It takes an escape of a drop of water from the size of an asteroid that fell another blade of glass and now rushing to you at breathtaking speed. You brace for impact, but instead of feeling a strong punch, you just get sucked in. You try to swim, but the water feels thick and sticky, holds onto your limb like glue. Air molecules like free spirits, but water molecules act like a social group whenever possible. They pull each other and create a relatively strong coalescing force that traps you. You can't help but moving, tumbling in all directions, helplessly dragged by an invisible current. Flowing in this manner like its lens of thousands of micro organs, they take many forms. Viruses the size of tennis ball float around you aimlessly. Others, like electric oxygen-rich cells, would pass you. Most are like oily jellyfish the size of the car, spotting long tentacles that act like supercharged propellers. Despite the water holding them glued, some move hundreds of body lengths per second, equivalent to a person shoveling at mud at 600 kilometers per hour. However, this bacteria weighs so little and water is so viscous that they basically no interior. There's no gliding on this scale. The result is a weird jerky motion that's hard to keep track of. Maybe we'll learn about this strange motion if we go deeper. The molecule realm. You have reached the size of a molecule just under 2 nanometers wide. On a new scale, the droplet seems to be as big as the moon to a regular human. The blade of grass is stretched from reach from the tip of Alaska to Australia, and the part now is almost the size of the solar system. But instead, most empty space is filled with stuff. Everywhere you look, there are innumerable amounts of molecules and atoms. The rigid walls of glass cells beneath were clearly vibrating of energy. Water droplets contain nearly 6 trillion molecules in motion. Water is smashing a stone home HO2 molecules up 16 times per second. Each of them is moving at speed about 2,300 kilometers per hour and bombard the surrounding mercilessly, sending a small object hurling in all directions. This is the source in the invisible current that you notice when you're 1,000 times larger. Scaling up to a human scale, it's impossible, as a human-sized molecule will be 2,000 times faster than the speed of light. As this furious motion, the heat is abstracted to our human scale when you touch something and get a vague sense of whether it's hot and cold. But down there, you can actually feel heat is the motion of molecules vibrating, twisting, and colliding in a ferrous ball pit. When these molecules lose heat, they move more slowly. And collide less often. When they gain heat, they speed up and smash together like amino flavors, and the temperature is basically the measure of an average speed of these fantastic tensors all day. Suddenly, your molecule hits you especially hard, and you are catapulted into a water droplet into the air again. Now, the stuff is unexpected. The stuff in care and molecules, nothing. And here, within the molecules makes up the air is a vacuum. On average, a molecule travels about 60 nanometers, a hockey rink if for a human, and if we compress all molecules and atoms buzzing around the room you're watching, and this will only fill about 0.1% of this volume. 99% in space is a vacuum. You just don't notice it. Which also means every time you take a breath, you breathe in mostly nothing. Just a few atoms. Click a symbiotic realm. At their size under 2 picometers, a scale starts to lose its meaning. A human would be nearly 2 billion kilometers tall relative to you, so large that you stretch your arm to Saturn. The atomic nucleus would be the size of a grain of salt if you hold on your finger. The grain holds 99.97% of atom's mass. At the rest, the sphere of influence as large as Eiffel Tower from the Pacific, filled with an electron cloud. That's basically the place where electrons might be giving at any moment. Electrons are shapeshifter and morph around outside nucleus, creating new and vibrating mess of different shapes at every moment. Unlike the graceful movements of planets, the atomic nuclei chaotic blurs, bulge, roll, quiver, and breathe. They hold out the same energy. The power sits in the nuclear bomb, and that doesn't let me. It sits still. The twist and vibrates 6 of times per second. It's time to end your journey and return to. What are you doing? Stop it. The smart place. We have reached the bottom, the border between reality and unreality. The scale, we have the Planck length, which the distance between light travels in a Planck time. Planck time it takes light to travel a Planck length. Okay. None of these models is the universe that makes sense at a smaller scale than this. So for now, it is. You think down here, particles bubble into existence and spontaneously disappear, creating a quantum foam of unimaginable energy. Can we go even smaller? We don't know. It's time to return. If you look at the universe, it's large and strange. So incredibly large and strange. But if you look down the universe, the universe seems even larger and even stranger. At the end, the perfect place is you are right now, not too big, not too small. So that's the end of the video. Thank you for listening. Goodbye.